Okay, so thank you for coming to my session. There are a million other things you can do besides coming to my session, so I appreciate it.
Sorry.
We're going to do it. There we go. Okay. I have a lot of stuff. My laptop actually started restarting spontaneously last Thursday, and so hopefully this will all work. I don't have slides, but I needed to flash some of the parts here. I've been working on FPGA IIgs for, I don't know, way too long. And I'm just going to do a show and tell what I have so far. There's a lot of stuff that works. Not everything works. I guess I'll point things out and we'll do some demonstrations maybe. And just things I learned along the way. Yeah. So, I guess hardware, everybody likes hardware. There's a lot of it here. And I guess my strategy here is there's a lot of peripherals in the 2GS. To make a board that replicates everything is a lot of work. So my strategy is to start with a run-of-the-mill development board and add on a daughter board per peripheral and get that working. And just keep continuing until I have a 2GS, right? It's that easy. I am getting into a kind of sticky point in that I'm running out of pins on my dev board, so eventually I will have to consolidate some of this. But every time I think I'm going to have to go ahead and make the final large PCB, I find another thing I can hang off the connector that's already there. So I'm going to show you what's here, and these are really dusty because some of these are old, some of them are new. And auto focuses. So we're going to do it this way. Is it? Oh, I'm sorry. I'm breaking my rule. I'm moving the camera around. You guys are getting vertigo. Okay, so what do we have here? Here's the FPGA dev board itself. This is a Cyclone 4 series from Altera. It is, you don't need anything special for 2GS. There's not that much hardware in it. You don't need that many gates. One thing I found that made it easier is to get a chip with a lot of RAM, like chip RAM built in. And the reason for that is there's 3 memory buses in the 2GS. There's the main fast memory, there's the Mega 2 memory, and the sound memory. And they all have separate buses. And rather than try and work on how I'm going to multiplex those together, I realized that 2 of the buses connect to very small amounts of memory. I'll just put those on the FPGA internally. Coincidentally, that's the fastest memory available to me. I'm using it for the slowest, the thing that has to run the slowest, but it's the most convenient. I'll have to change that later, to use external RAM, or maybe not, I don't know. So that's this board here. This huge thing is the sound chip, just a normal 8-channel audio DAC. It's on a huge board because I didn't want to lay out a board, and it's quicker to buy one. It's a lot more expensive, but it's quicker. So this is an Analog Devices DAC. Somewhere around there. Here. No, that's 8. Oh, here it is. Moving on. The 2GS. It has a separate micro. When they added ADB, there's this complicated protocol that connects to the peripherals, but they still wanted the normal, hey, there's a key press in this register functionality to work. So there's a whole another microcontroller that does that, and my version is the same.
although I'm not using the same chip. I just have like a STM32, this is like a discovery board, which I don't know why the connectors are on the bottom, but that's what they do. So everything's upside down. So the important part, I guess, is the top with all these wires. And that handles the keyboard and mouse. I've actually combined the clock chip and the battery RAM into it because this STM32 has a built-in real-time clock. So those are kind of combined into one feature. On the real hardware, there's a separate chip for the RTC. The clock works in my version, but I don't have a battery in my hardware, so like when you turn it off, it will forget what time it is. But it will work when I have the hardware. What else do we have here? RGB board here. I even color coded the wires RGB. Isn't that nice? My strategy starting with this project is a 2GS. I want to make everything that works on a 2GS work on this hardware. 2GS has RGB monitor. That's what I want to work. I know there are a lot of opportunities to use and like requests to use newer display types, and I think that's something I want to do. But like when you do that, when you change any of the peripherals, especially video, because of the way that the circuitry scans each line, like you have to sometimes make a philosophical decision of what part you want to not work the same way anymore. And I'm not ready to make that decision, so RGB for now. This drive, this is like the most recent one that I got working. So here we got the disk drive and a daughter card. Let's see here. No, we're too close. For the fabled, the 19-pin connector that nobody can find. Well, actually, you can find this one because everybody wants the thing that plugs into this one. They don't want the female version. They want the one on the cable of the drive that you plug in. So you can still get these, except you can't get a through hole, like a right angle connector. You got to have this little adapter and solder it that way. What else you got here? Oh, this is just to the power, distribute power. And then the dev board for the STM32 only has one USB port, so this is like a little tiny thing to give it extra USB. Wow, that's a lot. Okay. Let's see if it does anything. I'm not sure, like, I don't know, like, should I point the monitor at the audience? Then I want to put the camera.
Would you like me to hold the camera while you're working?
Yeah, that might help. Or I can like maybe just set it, like, because now I'm not in show and tell hardware mode. We might be able to just point it at the monitor. I have a few things to try. Not that part of the monitor, a little higher.
Yeah, there's a box.
This has promise. Ocean. I know. The chairs don't have 5 legs, right?
Yeah. What else can we get you?
And I also want to thank the KFest committee for accepting my talk. I literally told them only what is in the program, which is almost nothing, so thank you to them. In particular, I didn't tell them I had a lot of stuff to set up, so I'm sorry. I'm going to do it this way. Nothing works. Okay, so nothing is actually running on the laptop, but the FPGA is in a mode right now where, or the board is configured where it's loading its configuration from the JTAG port. So I do have to like start my computer to just a flash. So this one's in. Smoking. That's cool. All right. Let's see. Okay, I'm off. So, what's happening here? I have this little counter. The RAM or the ROM in the 2GS is right up on the main CPU bus and directly accessible. Today, like ROM is not really, I don't know, able to do that. So I have a serial ROM with the ROM image, and I load that at startup into RAM. So what happens is there's a very small program in like a pseudo-ROM in the FPGA bit stream that is actually a 65816 code that will read from the SPI port to load the ROM contents into RAM. And so after that, the top section of RAM is marked as read-only, so it looks like ROM, and then we never contact that memory again. And I don't know if you noticed too, like that was the address in the corner. It started at bank F0. The firmware starts at FC, I think, but you can put ROM disk or ROM tools as low as F0. So I was playing with those at one time. It's actually, I should have figured out why. This is not a fixed lens. Yeah. All right, so. That's kind of cool. All right, so where's my keyboard? One thing I did change from the original GS so far was I'm using the USB first. I do want to get ADB working originally, but they were so similar, like user experience wise, that I don't know, I was prepared to make that decision. So let's see if anything goes. Okay, so we got a control panel, maybe off the side. And just, I don't know, maybe I'll talk about bringing it up. One of the caveats is like not all the hardware is implemented, so I had to make new defaults for the ROM. Usually not everything gets a check mark when it's set to your card. For me it is, and also it's brown because that way I knew that my new settings were taking effect. So I'm going to enable the two slots that actually have something working. I guess what else can we do? Maybe show off video modes, sound. Oh, I can turn on the speakers. Sound may work. Let's see. Let's see. Does anybody ever do this on theirs?
Yeah. I used to.
Okay. I mean, I would play with it, but I would put it back to the check mark.
I like it super low.
Super low? Okay. All right. Well, good. There's a reason. See, every little thing someone's going to use. Okay, so now we said that. Let's see. Oh, I got to put a disc in too. Why do I have a disc in? Oh, no, I have that disc. We'll do this first. I was going to demonstrate the 5 1/4 first, but let's go right for super high res, I guess. Don't have the borders yet because it's handy to see what's happening, like where we're scanning, or what. That's kind of weird. A little fuzzy there on the camera. But yeah, so I guess in the course of this project, it was a while before I got anything working. So I got the CPU going, I was able to code that up, but nothing, you can't really test anything until you have software. And you can't run a lot of software until you have peripherals. So started with the CPU, tried to get video modes working, because then you can just load a RAM dump of video memory and see what happens. Got sound working, got the keyboard and actually just a keyboard at first. Concentrated on the 8-bit video modes. And then once I finally got the disk drive port working, then I can now, that's kind of where I am now. I can load stuff and see what was wrong. So a lot of stuff works, we boot. The mouse is the most recent thing that works. Can get a new stack.
For anyone who can't hear it, this is loading off of the 3.5-inch drive, an actual.
The real 3.5-inch drive?
Yeah, I have 2 drives. One of those. KFS 14. Thank you for our giveaway.
Oh, yeah. Glad you cleaned that up.
Just running normal GS speed.
Right. So what's the speed?
Fast versus regular.
Yeah. This is regular speed. So yeah. So you have the opportunity to make like built-in acceleration, and that's definitely possible. I haven't done that yet. The CPU, I say, does run faster. The bottleneck I have right now is, so I'm using DDR2 memory, and so in the Apple IIgs, you have just normal. I don't even know. Like that's. Yes, it's not static RAM, but like dynamic RAM, but it's not clocked. You put an address on the pins in a certain sequence with certain timing, and this many nanoseconds later you get your answer. And the way that's implemented in the Apple II is that all fits in a normal clock cycle. Modern memory doesn't work that way. You tell the memory, I would like this memory when you're able to, and then you have to wait a lot of cycles for it to appear. That's called latency, and there's different. That's all those numbers like 2-3.2 when you buy RAM for your desktop computer, and you get the bytes a lot later when you ask for them. But once that stream is opened up, like the bytes come flowing out very quickly. If you are able to keep that cycle going, you can get the memory, you can access memory very quickly. But in the case of the Apple II, you don't know exactly what memory you want. So you're asking for a byte at a time. So basically, the way it's implemented now, you go through the whole latency cycle
For every byte?
Every byte, yeah. So there's a very obvious optimization for caching because you get like 16 or 4, you get more than 1 byte back every time. And if you ask for bytes, 4,000, 4,001, right now in my implementation, it asks the memory twice and waits for that. So it's kind of weird, like I do have the FPGA implemented and it does go to fast mode and the CPU executes as fast as possible, but the memory slows it down and it's kind of about the same speed as a normal GS. So it just worked out that way. Yeah, I don't know, but yeah, I'm finding now, like as I'm starting to write more software, or like try and run more software, that like some of the things that aren't working may be related to like the clock speed, like maybe like especially sound, like if something has sound and then interrupt happening at a periodic rate, I think that may be taking more cycles. There's not as many cycles available for the main part of the code running in the normal context. So that might be something I'll look at soon. But yeah, so what's theoretical in this particular chip? CPU, I think it runs at like 40 megahertz right now with the simple optimization. Well, not simple, but like there's something I'm thinking of doing that I could probably double that. That's what I would do first. I can tell you about that. And then it's just little odds and ends. How can you speed it up a little bit at a time? But that would be the big one. So 80 megahertz. But this is a real GS, right? I want to make it work like a real GS, so I have a real 1 megahertz bus. So a lot of things will still behave slowly because you're accessing them the way they should be, the cycle accurate way. So I can envision a mode that like a control panel that you can turn off that mode or something so that you don't care. What?
Please.
Oh, yeah, so you don't have the 1 megahertz bottleneck for that. Because everything internal can run at the faster rate. It's just for compatibility with anything external. And I don't even have slots yet, so that was the big thing I need to make the separate board for. Did I answer the question? Kind of. Sort of, kind of. Okay, cool. I may have like requests for people with certain expertise. So we loaded the second disk of HyperStudio, and the mouse still works, but the pointer isn't being redrawn, and I think that has to do with interrupts. Like it's just not getting drawn correctly. So I don't know if we're gonna start a new stack right now. We can start a new stack, but we can't put anything there. You have questions?
The drawing of the cursor is done by V-blank, so if your vertical blank isn't working properly, then the cursor won't draw properly.
Okay, it's drawn on the V-blank.
Yeah, it's the V-blank.
Okay, so I do implement the V-blank and then also the almost quarter-second interrupt. But obviously it's working at some point and it fails to work. So maybe like the enabling of that interrupt or something like that is not getting restarted.
Or it's not getting cleared after it's being acknowledged.
Yeah, something like that. Okay, I can look through that. Okay. There is the 2GS stuff, or the, I guess 16-bit stuff. I also wanted to show some 8-bit stuff, because the 2GS can also do 8-bit stuff. And it does it in a slightly different way than a real, like a Apple II Plus or 2E does.
Question.
Yes.
What exactly are you doing for the CPU? Is that emulated, or you have a real one that you're running fast, or what?
It is it's emulated, so the CPU is written in the same, in the HDL. So it's part of the FPGA bit stream. And that was like the first part I did.
Okay, so you wrote the CPU emulator for the.
Right, so we have like a cycle accurate 65816 core in Verilog right now. Okay, we might have been. Oh wait, I need that. We want it slow. Let's try again. I found the problem. And I picked arbitrary things that I had lying around. That's how various video modes.
Mario Bros.
Yeah. We called it.
We know what that is.
I play it a little too much.
Somebody likes that
Yeah, I like this one. So we're gonna take that sound. But I guess so. One thing I will point out. So the 1-bit sound is working. I don't know a good example, but like I guess you can notice like the fringes that would be, you have the NTSC artifacts on the 8-bit Apple IIs. And then when Apple made the video controller in the 2GS, they wanted to fix it. And now, if I did air quotes, I would do air quotes now, but I don't do air quotes, so I'm not going to do that. But fix. So.
Kind of having it both ways, though, by saying.
Some of us like it.
But so they tried to fix some certain artifacts, and they introduced others. So, anyways, Jeff, is it Jeff Boddy or Bodie? I don't know if people familiar with Jeff Bodie. Bodie. He found the patent that for Apple II's circuit that does this NTSC decoding. So that's implemented here. One of the things I designed the hardware for, but haven't implemented yet, is like while I do like this and I want this to work too, like I also really like the way that the 8-bit modes work on a composite CRT, so I want to include that output as well. And I wasn't going to include the 2GS's or composite from the RGB until Dave Schmenk did his session the last year, and now I have to. So maybe that'll come around eventually. We only got 5 minutes. Okay. Here's another arbitrary game. Let's see. Going back on. I know there are a lot of DIS2 and IWM people here. That's a newer feature that I've implemented. I might have some questions on that. I'm able to read up most disks, but it's still kind of temperamental and, in this case, a little slow. Like it's seeking for a sector, not finding it on the first pass. The part I'm not sure, like there's also the patent for the IWM, and like there's a specific spot where it tells you how, when the high bit is set in a nibble song, oh, here we go. It freezes the data register, and a particular mechanism uses to stop that. And I did it according to the patent, and it didn't work. Or at least I thought it did, to my knowledge. So either I'm wrong with my implementation, or the patent has a little sneaky trick.
That part is also described in beneath Apple ProDOS, the logic state sequencer.
Okay, was that the IWM though? That's just
Well,
the
that's
DIS2?
the same thing.
It's not the same, that's fine. I mean, I guess I could implement the DIS2 one, and then that may work. But yeah, because you have the asynchronous modes too in IWM, and they, you have this extra hardware to support the asynchronous mode, but it still has to be useful for the synchronous mode. So we were fortunate. I chose this one because it has double high res, and it has the wheel, and it, with lots of colors, continuously, like, the barrier between the colors is changing on different pixel boundaries, so, let's see that. And then, I'll spin the wheel, that'll be it for that, and then I have one more disk to boot up and show, but that has a lot of stuff that doesn't work, so let's see.
That part works, please wait.
Yeah, please wait. See, this is the part where I think it's faster on the real hardware, and if I change the delay that the byte is being held in the register to make it longer, some other things begin to work and some other things begin to not work. So, it's tuning. But yeah, we got the 2GS style, I guess, double high-res pixel boundary, right? Oh no, oh no, oh no. Yes. All right. Guess I'm low on time.
So is the Sonic implemented in the FPGA as well, or what's?
Yes, and so that's implemented. I'm actually like an audio, like a music hobbyist as well, so that was a fun part. But it's one of those things where it's implemented and most of it's there, but now I have to run it with real software to find what doesn't work. And that was a wonderful segue. I didn't prompt this guy at all.
What stuff are like the things that aren't done yet?
Big things that aren't done? Well, the slot interface is a big thing that's not done yet. The serial ports are not done, but you can actually still buy the chips, the Zilog chips for the serial port. It's like 3 generations or 2 generations newer than the ones that are in the 2GS, but they're supposedly compatible. So that they're not done. Those are probably the main things. I'm sure as soon as I think about something else I'll remember. Yeah.
Do you support any type of acceleration, and what other features does this, have you implemented or looking at implementing that expands over a real 2GS?
Acceleration. So yes, and it's I'm not even sure you want to call it acceleration, but I will. The reason is because in the 2GS you have the 2.8 megahertz. If you have a fast cycle and a slow cycle, and that's all you get. And so you have to tack on extra hardware to have this, third layer now running at a faster speed and then talking to the rest of the system. Because I'm re-implementing the base hardware, that 2.8 megahertz now can be 40. So it's kind of like built in. If I fix some other bottlenecks, the fast cycles just become faster, but they work the same way that they work on the real 2GS hardware. And like new features, I really haven't thought about that too much. I want to keep my focus.
Trying to get accurate first.
Yeah, I want to get what works on the 2GS working first. I mean, there's tons of stuff you can think about. That's one reason I didn't give this talk in the past, because I'm worried about people telling me, oh, how come it doesn't have this or that, to tell you the truth. So that always comes up on CSA2. I don't want to go on a rant, right? Somebody spends a lot of time working on this implementation, for whatever, 6 or 12 months, and somebody says, well, why doesn't it do it this way? It's like, because they did it.
That's how it is. Show some respect.
Yeah, so.
No idea what you're talking about.
I'm not, and this is the weird thing, is probably the thing I'm thinking about is totally different than what you're thinking about, but it happens. So, I don't know why I said that, but yeah, I was kind of concerned about that, but I can handle it now, I think. What do I want to add? Obviously, anything mechanical that's going to be breaking down, we're going to have, like the video. One thing this monitor, I got an extra one at the garage giveaway because they're going to not work. So, like mass storage, I would like to add. So maybe things that are on a Mark Twain, there's SCSI card on the Mark Twain. That's a reasonable thing, but like maybe like CFFA 2 level where it's mass storage. You're going to have this philosophical debate, like, do you want to put a floppy drive emulator on this if it's really an Apple 2GS? Maybe you do, but then again, you can stick a CFFA 3000 in it, or you will be able to. So I want to add like base level improvements that for things that people had, pretty much across the board, like everybody had after a certain point, I guess, in the 2GS lifetime. All the people that still used it had a hard drive. Things like that. And also like the peripherals already have USB keyboard and mice supported. Oh, right.
We gotta be done.
We got to be done.
Yep.
So somebody asked about the Ensoniq. I will boot up something. Oh, did I change the startup slot? So this is FTA.
Sounds like a fast loader.
So modulate. You can hear sound repeating because there's a flag in each channel in Sonic that tells you if you want to play once or a loop. And so there's something not right with that. And then we can load, 320 or, it's not 320, it's 640. So we get sound, but this is where this one ends. It's forever decrunching. So we do have sound. That's kind of all we have now, I guess. So that might answer the question.
Can you trigger the Easter egg in the round 3 for the where everyone shouts Apple II and you go and Control N or something?
It does work. In fact, I used that a lot when I was testing the sound hardware. I actually don't remember how to do it.
Just real quick, it is 12. It's time to go to lunch. If you want to stick around and continue to watch this, you certainly can. The next session after this will start at 1:15.
All right. Thank you, everyone who is.